All right, folks. Thanks for coming. We kick this thing off with Algebra One. Algebra One is the same thing. Sometimes they call it as elementary algebra. Then after that, we go to college algebra, or what they call Algebra 2, right? Then after that, we'll go to trigonometry. Then after trigonometry, I'll go to pre-calculus. I may decide to just, do different things. Like I may decide to do some Algebra 1, then some Algebra 2, then some trigonometry, some pre-calculus, as we go along. I haven't decided yet, but I may just concentrate on Algebra 1, finish it before I go to Algebra 2. Now, you have to realize that there may be repetition from what I did in arithmetic. We may repeat some stuff. Algebra 1 may repeat something we did in arithmetic. Algebra 2 may repeat something that is covered in Algebra 1. Trigonometry may repeat some stuff we covered earlier. Pre-calculus may repeat some things in Algebra 1, Algebra 2. So that's how it goes. So it's not, there's nothing wrong with repeating. If it repeats, it just gives you opportunity, to learn what you learned in the past. So that's how mathematics goes, you see. One class repeats a little bit what was done in another class. And there's nothing wrong with that. So like I said before, all these different classes are required by different majors. For example, somebody in economics major may take Algebra 1 and Algebra 2 and trigonometry and pre-calculus, right? And somebody in nursing may be required to take Algebra 1 and then the trigonometry without doing pre-calculus. Somebody going to medical school may take pre-calculus, and then they may be required to take calculus 1 and 2, something like that. Different majors, require different stuff. So that's why I want to cover everything. You can say, well, why don't you just jump to pre-calculus, since it contains a little bit of trigonometry and a little bit of Algebra 1, Algebra 2. Yeah, I can do that, but then some people that need help in Algebra 1 will not, get help from my videos, right? So that's why I want to cover all the bases. That way we can, we can be exposed to different audiences, right? So what we're going to do, we'll just start with Algebra 1. We'll start with Algebra 1, then we'll cover most of the topics there, and then we'll go from there. Before we continue, please subscribe to my channel, like and share this video, leave comments or questions under this video. When I have time, or if I make out time, I will answer your questions, okay? Now, let's kick this thing off. The first thing I want to cover, the first topic I want to cover is variables and algebraic expressions. Variables and algebraic expressions. All right, what are variables? In mathematics, variables are, you see stuff like x, y, z, a, b, c, t, stuff like that. These are usually called variables, right? They are called variables. They are used to represent numbers. Okay, They are used to represent numbers, and they allow us to generalize, right? To generalize. That means to generalize basically means to abstract. It means to abstract from different what I call algebraic different algebraic situations, right? Yeah, this will make sense to you as I go on. Different algebraic situations. Now, so that's what you understand are variables, right? Now, what of expressions? You use variables. You use variables to create expressions, right? So we can write x plus y. This is an expression. This is an algebraic expression. Algebraic expression, right? Okay. So when you combine variables using the, remember we talked about several I think 4 basic operations in when we did arithmetic. You remember we talked about addition, subtraction, multiplication, and division, right? I also talked about exponentiation. So you use variable, then you form all these types of operations in algebra, right? So you can say, like I said, you can say x plus y. This means the sum. It means the sum of any two numbers, right? That's what that means. Where x is a number, y is a number, right? So that's what you're looking at there, the sum of any two numbers. Right? Now, we can also write this. We can write this like this. 2x plus 4y. Again, that represents another algebraic expression. Now notice that 2 is put in front of x, 4 is put in front of y. Right? That means 2x means 2 times x. 4y means 4 times y. Right? That's a simple way, abstract way of representing. Instead of writing 2 times x plus 4 times y, mathematicians just use an abbreviated form. They abbreviate that to that, and then notice this. We cannot. Notice what we cannot do. We cannot write the above as this. We cannot write x2 plus plus y4. I mean, it will confuse. It's confusing. We don't write that like that. Okay, because it will be confusing. I mean, it will make sense in terms of what they call associative or distributive laws of arithmetic. But this is the best way. The best way to write it is this way. That's the way you read it in books. You won't read that in books, okay? So we can also write. We can write this. We can write 2 pi plus x raised to power 2, right? So that's exponentiation right there. So, or we can write 6y times 10 like that. We can write it like that, which is the same thing as that thing there is the same thing as 60y, right? So but anyway, yeah, these are different ways we can write stuff. As I said before, recall that we dealt with a lot of expressions. We dealt with a lot of operations, right? Especially we dealt with 4 basic math operations when we did arithmetic. Remember? So we dealt with multiplication. We'll start with addition. We talked about addition, right? Addition and subtraction, right? And then we talked about multiplication and division, right? And then we also, somewhere, these are the 4 basic operations we do. But somewhere we also talked about exponentiation, right? Exponentiation. Basically, that means you raise something to exponent, right? That's what that means. We talked about that too. Talked a little bit about that. So these 4 basic math operations, they are very, very important in the first algebra class. So let me show you. I show you this. I will show you this table. Let me list this table. It will help you to understand what we're gonna do. Now check this out. Let's say we say operations, right? And then we'll say arithmetic. And then we'll say algebra. And then we'll say vocabulary, right? Vocabulary. This is vocabulary you need to know. So let's do this table like this. Okay. All right. Now, let's say I put addition here. These are the operations we'll do. Addition, subtraction. All right. Multiplication. And division, remember? Okay. Let's do it like that. Let's do it like that. Let's do it like that. Let's do it like that, okay? Now, suppose I say addition, I say 3 plus 8, right? In algebra, we can represent 3 and 8 with variables. Then we say x plus y, see? And that means in algebra, x plus y means the sum of x and y, okay? And then in doing subtraction, we can say 10 minus 4. We can write it like this, a minus b, using variables. A and b are variables, right? And then we'll call this the difference, right? The difference of a and b, okay? And then multiplication, we can say 6 times 2, right? These are numbers, right? And then we can use variables to represent that. We can use, any variable. Let's use A and B. We can say A times B. That's one way to write it. Or we can say A times B like that in bracket. Or we can say B times A, the same thing. It all means the same thing. Or we can say A times B like that. Remember? Or we can say, as I said earlier today, AB. It's the same thing. Or you can even use bracket, A, two brackets, and B like that. Right? So all this means the product of A and B. That's all that means. The product of A and B, okay? Now, division. Let's say we say that, remember when I covered the arithmetic operations, if you haven't watched my video on that, go watch it. You'll see what I covered there. I covered a lot of stuff there. Let's say we say we want to do 12 divided by 4, right? That's how we'll write it. Or we can write it like this: 12 divided by 4, the same thing. Or we can say 4, I'm sorry. We can say 4 over here. We'll put 4 outside and then we'll draw this thing, put 12 in there. Those all mean the same thing. I'm sorry, 12 divided by 4. I didn't put that. So these are different ways you can say the same thing, right? These are different ways you can say the same thing. Remember, we covered all these, But anyway, so you move to the algebra side. Let's use A and B to represent 12 and 4. If you move over there, you can say A divided by B, or you can write it like this: A over B, or you can write it like this: you put B, the divisor, and you put the number being divided over here like that. They all mean the same thing, right? Now, the vocabulary you pick up from there is, you said the quotient. The quotient of A and B. That's what you pick up from there, okay? But anyway, so this table right here shows that we can write algebraic expression in words. In other words, we can translate addition. We can translate addition in words right there. We can translate subtraction in words. We can translate multiplication in words, right? We can translate division in words. That's all this stuff is saying. I will give you examples, okay? Let's find you examples. All right, let me show you examples of what what the table up there represent, the vocabularies in the table, right? Now look at number 1. It says 20 less than x, and number 2, 8 more than y. Number 3, the product of x and 40. Number 4, the quotient of x and 7. Number 5, the difference of x and 10. These are words. You will use words to write algebraic expressions, right? Now we'll have to translate it into mathematics, okay, into algebra. Now if you look at that carefully, read that carefully, and then you can cover. I'm gonna give you the answer in a minute. You can cover. After I give you the answer, cover the right hand side, cover the answer, and then try to see if I can come up with the answer yourself. It will help you, really help you to understand what is going on in algebra, okay? Now, 20 less than x. Basically, that means you have a number x, and then 20 is subtracted from it. So it would be x minus 20, see? That's what that means, 20 less than x. Okay. 20 less than x. Don't be confused. Don't think you take 20, you subtract x. No. 20 less than x. So try to make sure you understand that. Then the second one is 8 more than y. 8 more than y, the way you write it is y plus 8. Okay? Yeah, try to understand those two. Try to read them carefully until you get it. Alright, look at this one. The product of x and y. The product of x and 40. That is written like this, 40x. That's what that means. And then look at this one here. The quotient of x and 7. Right? The quotient of x and 7 is written like this, x over 7, right? Now look at this one here. That one it says that the difference of x and 10. Alright? So it's x minus 10. So the best way to remember this is, see, the variable is written first. And then after you write the variable, then the next thing is the number. The difference of x and 10. You write the variable first. 20 less than x. Right? You write the variable first and then subtract 20. 8 more than y. You write y first and then put 8. Add 8 to it. Okay? So that's how you understand that. I'm gonna give you a little more other examples, okay? Alright, look at this example here. It says 24 more than 3 times her age. 24 more than 3 times her age. So you get her age first, right? And then you have you multiply her age by 3 times her age, and then you add 24 to it. That's all that is saying. So, but the best way to do it, we say let x represent her age, okay? Let x represent her age. Then it says 24 more than 3 times her age. So what that is saying is 3 times her age is right there. And then 24 more, you add 24, right? That's all that is saying. 24 more than 3 times her age. Okay, look at the next one. It says 21 less than 4 times the wheat. So the same idea, there is a wheat. There is a wheat of something. You multiply it by 4 times the wheat. And then you subtract 21 from it. That's all that is saying. So try to understand what that is saying. Always follow the variable. Here the variable is her age. Over here the variable is the wheat. So you say let x be the wheat. Okay? That's all. Let x be the wheat, right? And then he says here 4 times the wheat. You see? 4 times the wheat. So we say 4x, right? And then he said 21 less than 4 times the wheat. So you subtract 21. That's all. That's all that is saying, man. That's all that is saying. Don't let that confuse you. It's you just have to read it carefully. Take your time. Read it carefully. Try to understand what it's saying, and then you should be fine. The next thing I have is let's define an equation. What does it say that something is an equation? The definition there is an equation is a sentence that says 2 algebraic expressions. You see, we explained algebraic expression before. It says a sentence that says 2 algebraic expressions are the same by using an equal sign. This is an equal sign here, okay? Okay, I'll give you an example. Suppose you are given this thing here. Says it says 24 plus 20 is 44. See, 24 plus 20 is represent the equal sign. So what that is saying is 24 plus 20 is equals to 44. Okay, see, that's what that is saying. That's what that is saying. So this is just like what equation means. Equation, you equate two things. You equate one expression to another expression. This is an expression, this is an expression. You can even say x plus y is an expression. You can equate it to 4x, something like that, and then you solve it. We'll get to that later. We're going to get to that much later. Alright, let's look at another example. It says, read it carefully. It says, the area of a rectangle is the product of the length and the width of the rectangle. Is tells you is an equal sign there. But anyway, again, you start by saying, but it's talking about the area of the rectangle, and then they have width and then you have length, right? You start by saying let A be the area of the rectangle, okay, and let L be the length. That way you can translate it into algebraic expression. Okay, let W be the width. Okay, and then you say, now read it again. You say the area of a rectangle is the product of the length and the width of the rectangle. So basically you say area is equals to length times width. That's all that says. Okay, so try to read that, try to understand what he's saying, and then you form the equation. Now let's look at this example here. It says the number of books in Jerry's bookshelf is 6 more than twice the number of books in Paul's bookshelf. So what you do, you start the way we started in the previous example. You say let X be the number of books in Jerry's bookshelf, and then you say let Y be the number of books. Let Y be the number of books in the number of books in Paul's bookshelf, right? And then make sure you try to understand what it says, the claim made up there in the statement of the problem, right? It says that first of all, notice that this is the is a sign of two things are equal, two expressions are equal. But it says twice the number of books in Paul's bookshelf. So if Y is Paul's bookshelf, so twice means like that. And then keep reading. It says 6 more than twice. So you got 2 Y's, then 6. You add 6. And then don't forget the number of books in Jerry's bookshelf is. So Jerry's books, X represents Jerry's books. So you say X is equals to that. That's all that is said. Read that until you understand it. That thing says X is equals to 2Y plus 6. Now, that would be a situation where you are given numbers, try to find out the actual numbers, right? Okay, let's say that Paul's bookshelf actually contains 40 books, right? And then the question is, how many books are in Jerry's bookshelf? So using the stuff you found here, the equation, and then given this, you can solve the problem, right? Because what that is saying, basically saying there is what that question is saying is that y is equals to 40, right? Because y represents Paul's the number of books in Paul's bookshelf, right? And then if y is 40, then evaluate x equals to 2y plus 6. That's all what it's saying there. Evaluate. We've done that before. Evaluate, given that y is equals to 40. So what you do, you say x equals to 2. You substitute the value of y, 40 plus 6, and then you keep going. That's 80, right? Plus 6, and that's 86. That's all. That's all that is saying, man. Don't read more to it than it says. Okay, let's look at another example. It says the number of girls in a class is 3/2 of the number of students in the class. So you start by doing the same thing we did in the past. Let x represent the number of students. Let y represent the number of girls, right? And then you form the equation based on what is given. The equation should be just y equals to 3/2x, because it says 3 of the number of students in the class. See, of right there means multiply. So it's 3/2 multiplied by x. So you get that, right? And then supposing the number of students in the class is 40, then how do you find the number of girls in the class? So basically, what that is saying, that thing is saying evaluate y equals to 3/2x when x is equals to 40. That's all that is saying, right? Because the number of students is x. So basically you evaluate that. What you do, you say y equals to 3/2x, right? And then you substitute the value of x. If you substitute, you get 3/2 times 40. That's all. Okay? So again, remember what we did when we did arithmetic. If you can cancel something, cancel it. Cancel 2 here, cancel 2 here, 40, you get 20, right? And then you say 3 times 20 is equals to 60. That's it. That's all you're looking for, okay? Very simple. Okay, look at this example following the, what we'll learn from the previous example. Look at that. It says evaluate x plus 4 all squared minus 2x when x is equals to 1. That's what we did over here, see? So you're evaluating an expression given a value, right? So what you do, you take x equals to 1, you substitute it in this expression here. So basically you have x plus 4 minus 2x when x equals to 1. It becomes 1 plus 4 minus 2 times 1. That's what that is saying. Alright? That's what that is saying. So it becomes 5 squared minus 2. That becomes what? 5 times 5 is 25 minus 2. And that will get you 23. That's all. That's all that is saying, man. Let's look at another example. It says that evaluate these two expressions when x is equals to 1 and y equals to 2, right? So we have two expressions to evaluate. We have x times y cubed, and we have x times y, only y is cubed, right? So to evaluate this, you just put these values, right? It's 1 1 times 2 all cubed. So what does that mean? It's 2 cubed. That basically is 2 times 2 times 2, which is what? 8. 2 times 2 is 4, 4 times 2 is 8. And then this one here, you go 1, right? And then 2, only 2 is cubed, you see? So basically anything times 1 is that thing. So it's basically 2 cubed. See the same thing, 8, okay? So, but anyway, that's the example there. Let's look at another example. Let's say it says evaluate this thing here. Evaluate this, evaluate the expression when x is 2 and y is 3. So basically you say 6 times 2 plus 5 times 3. That's all. Evaluate that. It says 6 times 2 is 12 plus 5 times 3 is 15. You add that thing up, you get 27. All right, that's the answer we're looking for there. You see, so okay, let's look at this example. You say evaluate the expression when x is 2, y equals to 3. Again, you do the same thing. You say 3 times 2 plus 2 times 3. You just put these values in the equation, okay, in the expression. And then 6 times 2 times 3. That's all. So you simplify. This is 6 plus 6 plus 6. 2 times 3 is 6. 6 times 6 is 36, okay? So you keep going, 6 plus 36. And then it's 12 plus 36. And then it's, what is this? It's 48, right? So that's the solution there. All right, let's look at that. Say find the value of that expression when k is 2, a1 is 4, a2 is 3. I formed this example on purpose to show you that one variable, like you see where it says a1, a2, those it's called subscript. So a1 is a subscript, a2 is a subscript. I just want to show you that those are two different variables. a1 and a2 are two different variables. So when you see something like that, don't get confused. You see, it's the same thing. All right. So to evaluate that, we just put the values given to us into the expression, right? You see the values given to us. So we say k is 2. So it's 2 times a1 is 4 plus a2 is 3 right there, and the whole thing over 2. Okay, so it's simplified. How do you simplify? Starting from inside bracket. The next topic I would do is order of operation. That will, even though I did it when we did arithmetic, I will do it again to refresh our memory. So you start from the bracket. What do you do? If you do the bracket, you get 7, okay? And then you multiply it out. In fact, you can cross things, cross that out. The answer is 7. So remember we did that when we did arithmetic. If you can cross something out, cross it out. You're not breaking any rule, okay? So that's the solution right there. Okay, let's go ahead and solve this, simplify these expressions. I formed this on purpose to use it to remind you what we did in arithmetic. Again, if you didn't watch my arithmetic video, go and watch all of them. You'll learn a lot of stuff from there. Now, you see, when you multiply a negative number by a negative number, what do you get? You get a positive number. So the first one there is, that thing there is 8. Because the negative cancel each other, right? Now look at the second one. When you multiply negative by a positive number, what do you get there? You get minus 8. Alright, when you multiply a negative and a negative, you get positive number. You multiply with another negative, then you get negative number. So that thing is basically it's right there. 9 times negative 2, that's negative 18. Okay, just go back to my arithmetic. I explained this stuff very well. You'll learn that from there. Now look at this. When you have a negative dividing a negative, right? What do you get? You get a positive number. Okay, it will give you 6. It's just like negative cancel negative. 24 divided by 0. Again, by mathematicians, this is undefined. There's no way you can divide by 0. It's not defined. What of multiplication by 0? Yes, that's 0. If you multiply anything by 0, you get 0. So I just did this on purpose for you to refresh your memory. If you don't understand any of this, again, go back to my arithmetic videos. You will see I covered that extensively there. Okay, I just want to refresh your memory on what is called the order of operations, right? I covered this in my arithmetic series class, right? I told you I was trained on what I call board mass. There are different other acronyms, but this is the one I like to use. The B stands for brackets. See, brackets, sometimes they call it parentheses, right? O stands for orders, like powers, exponents. That's what that stands for. D and M will go together. That's multiplication and division. AS is addition and subtraction. Now here is what is going on. See how it's written? You always go from left to right. You always perform operations from left. See where my arrow is going? Left to right. So you have to do brackets first. You do brackets, or what you call parentheses, first. That has to be done first before you do exponents and square roots. Right? You do that second. After that, you keep working from left to right. After that, then the next priority is multiplication and division. Then after that, you do addition and subtraction. So these are the orders, right? You do this first, second, third, and then fourth. Working from left to right. That's all that says, man. If you keep that in mind, you're not gonna go make a mistake. All right, let's do that example there. You just have to follow the acronym board mass, right? Now, you always, like I say, you work from left to right. Now you look, what do you see? You see division, and then after that you see subtraction. After that you see multiplication. So as long as you're going from left to right, you're fine. From left to right, do the division first, okay? When you do the division, what do you get? You get, you get 10, right? And then you write the rest of the stuff. Just keep walking left to right and rewriting stuff if you have to. And then again, work from left to right. You can't do the subtraction first. You gotta do the multiplication first, okay? And then you say 10 minus 4 times 2 is what? Is 8 plus, and then you do the multiplication over there. It's okay to do it at the same time. It's 18. Okay? And then you keep working from left to right. Now you can do subtraction and addition, working from left to right. 10 subtract 8 subtract from 10, what do you get? You get 2 plus 18. So you finish up, what is that? 20. That's your answer right there. So the trick is to go from left to right. Don't jump all over the place. You start jumping all over the place, you're gonna have problem, okay? So let's go to look at another example here. So you go from left to right, You can't do the subtraction first. You gotta do the multiplication first, right? So when you do that, what do you get? You get, as you go, you write stuff out, okay? 20 minus 18 divided by 3 plus 12 minus 14 times 2, okay? And then you continue from left to right. What do you do next? You do the division next. You keep it rewriting. 18 divided by 3 is 6. You get 6. So you keep rewriting stuff. Minus 14 times 2. Okay? Now, what do you do next? You can't do subtraction. You can't do addition. You gotta do this multiplication that is at the end. So you do that first, but you rewrite stuff. 20 minus 6 plus 12 minus what? See? 14 times 2 is what? 28. So you write it like that. You keep working from left to right, okay? Now you do 20 minus 6 is what? Is 14 plus 12 minus 28. You're working from left to right. 14 plus 12 is what? Is 26, right? Minus 28. And then you finish up, that's minus 2. That's the answer you're looking for, okay? So go through it the way I did it. You go run it back and forth, and then until you get it right, okay? Now, let's do another example. Look at this one. This has exponents. It has an exponentiation in it, that one there. So what you do, you gotta do that. By the way, you walk from left to right, but you do what it's supposed to do first. Okay, so that one has exponentiation. You do that first. So, but you rewrite 6 plus 22 times what? After you do that, that exponent is 3 times 3 times, 3 times 3 times 3, right? You get 27. 3 times 3 is 9, 9 times 3 is 27. So you write that down, 27. And you keep working from left to right, rewriting whatever you need to. You can't do addition first. You do multiplication first. You say 6 plus 2 times 27 is 54, right? 54. You keep working from left to right. Okay. So 6 plus 54 is 60. And that's your answer right there. All right? Okay. So we'll do this example, okay? Again, you walk from left to right, but you have to do the exponent first. So you rewrite stuff 5 times 6 plus, now 4 times 4 times 4 is 64. So you write that down and then keep working from left to right. The first thing now, you do the multiplication first. 5 times 6 is 30. So you rewrite that 30 plus 64, right? And then you add, you do the last one, the last addition there, you get 94. Okay, so that's how you do it right there. Now let's do the next one. Look at this one. Again, you work from left to right. You gotta do the bracket. If you see bracket, you have to do it first. Left to right, but you do the bracket first. So you write 4 times, what is that in the bracket? 2 plus 8 is 10, right? 2 plus, you get 10 right there. And then you bring 9 down, minus 9, okay? And then you do the multiplication first, working from left to right. It's 40 minus 9. And then you do subtraction, the last one is 31. That's the solution right there. See, so just keep following the rule. If you keep following the rule, you shouldn't have any problem. Don't jump all over the place. Look at this next one. Again, this one contains fraction, but it's okay. And it contains the exponent too. So you keep working from left to right. Now, what do? You're going to do the exponentiation first. Okay, so that exponent there, it says 2, it means 2 over 3 times 2 over 3, because that's what that means. That square, that's what that means. So that would be 4 over 9, you see. So let's rewrite everything. 2 over 5 plus 3 over 2 times 7 over 3 minus 4 over 9. See, that's what that means. So working from left to right. Okay, you keep working from left to right. What is the next thing to do? You gotta do multiplication first. Okay, so if you want, you can put brackets like that. That way you know you gotta do that first. So you rewrite 2 over 5 plus whatever you get in there. Notice that this can cross that. Whatever can cross it. You're not breaking any rules. 7 over 2. That's what is left in there, minus 4 over 9. Okay? So you keep going. Now what happens is, I covered this in the arithmetic section. You gotta find the common denominator, because now you have to do addition. You gotta do addition first, and then after that you do subtraction. So what is the common denominator of these two here? I think it's 10. So you can use 10. 10 will work. You say 5 divided by 10 is 2. 2 times 2 is 4. So you get 4. You say 4 over 10, like that. Okay? Say 2. You say 2 divide 10, you get 5. 5 times 7 is 35. Okay, so it's 35 over 10. See? So you add those two, you get 4 plus 35 over 10, because now you have a common denominator. It would be 39 over 10. Okay? Now don't forget, we're just doing this. So then you're gonna continue with what you were doing. So you rewrite the problem, you get 39 over 10 minus 4 over 9. So you continue, see? Alright? So again, you do the same thing. You have to have a common denominator. So what will work? 90 will work. Now we'll do it a little bit different. 10 divide 90, right? Or you say 90 divided by 10, you get 9. 9 times, you can do it like this, 39 times 9, right there. Minus, and then you say 90 divided by 9, you get 10, right? And then you say 4 times 10, like that. Okay? So you simplify that. What do you get? You get 351 minus 40, all right, over 90. So you simplify that, you get what is that? 311 divided by 90. Okay, so that's your answer right there. You're done. That's what you were looking for right there. All right, folks. I'm gonna conclude this video with Cartesian coordinate system. You remember I talked about this when we did the arithmetic series. Basically, Cartesian coordinate system is what it's gonna appear over and over again in algebra. All algebra classes, even calculus, it appears all over and all over again. So another name it has is it's called rectangular coordinate system, rectangular XY plane. They have different names for it. Okay, basically what it is you draw a vertical line and then a horizontal line, right? And then you label this x-axis, and you label this y-axis, the vertical line y-axis, right? And then Over here where they meet is 0, 0. It's called origin. That place is called origin. Yeah, that's the origin right there. Okay? And then, there are quadrants. I don't know if I talked about this in the other class, but there are quadrants. This is the first quadrant. It's called the first quadrant. That's how that's spelled, quadrant 1. They use the Roman numerical letter to represent 1, 2, 3. And then this is quadrant 2 right here. Quadrant 2. Okay, and this is quadrant 3. There are 4 quadrants, right? Quadrant 3 right here, and this is quadrant 4. Quadrant 4, okay? Notice that the quadrant goes in counterclockwise. It starts here and then it goes like that, okay? Yeah, the Cartesian coordinate system is, like I said, is very, very important. If we draw a graph, anytime you draw a graph, you're using that, using that to represent your graph. I'm going to draw another one right here. And then right here, this is x-axis, y-axis, okay? Now, the thing is any point in the Cartesian coordinate system is represented by what is called an ordered pair, right? An ordered pair because let's say we have this point here. First of all, you have to label the system. You label it simple, 1 here, 2 here. Choose here any scale you want. Any scale that is good for the problem you're solving. 5 here. And then 1, 2, 3, 4, 5. Alright. 6, 7. Okay. And then these are negative. Over here is like -1, -2, -3. The same thing. On the left of 0, -1, -2, -3, and so on. Alright. So any point anywhere in the coordinate system is represented by ordered pair. And then the first number in the ordered pair is x. The second number is y. So that's how you can't put y first and then x second. No, x has to be first. So this point here, what you do, you go down here, find the x coordinate, which is 3, and then you go here, find the y coordinate, which is 5, and then he said that point there is represented by 3 and 5. That's how you do that. So generally they say x and y, because that's how it's represented, right? Right here, x and y, okay? So it's 3 and 5 right there. Okay, so they can give you an ordered point, an ordered pair, and say find that ordered pair in the Cartesian coordinate system, right? So let's draw another one. That way you can see what I'm saying right here. You can always draw as many as you want. This is x, this is y. Let's say they give you a point. Let's say they give you this point 6, 7. Don't forget the 6 is x, the 7 is y. And they want you to locate it in the Cartesian coordinate system. So what you do, you start by drawing the system and entering point using the appropriate scale for the problem. So we can scale it like this. This is 1, this is 2, this is 3, this is 4, this is 5, this is 6, this is 7, right? And then we'll go up here too. This is 1, 2, 3, 4, 5, 6, 7, okay? And then you to locate this point, you follow 6 on the x-axis, and then you go up to 7. See, that's 7 right here. So you follow 6 to 7 right there. So where they meet right there. So this is 6, 7. Okay. So this coordinate Cartesian coordinate system is very, very important when you're dealing with the linear functions. We're gonna get into that a little later. When you dealing with linear functions, right? So you have to use this to plot the graph of that function. So you can also be given a bunch of points, and then you are told to connect the points, right? Okay. So supposing they give you these points, these are 4 points, and then they want you to plot it and then connect the points, right? So what you do, I've drawn the system already with the axis label. So you start with 0, 0. 0, 0 is right here at the origin. You put it right there. That's 0, 0. Let me see if I can make this a little larger. That way you can see a little better. Okay, 0, 0. Then what is next point? 2, 5. 2, 5, x, 2, y, 5. So you start from 2 and you go to 5 right there. 2, 5 is right there, okay? 2, 5. Okay, and then the next point is 5, 10. You start from x5 to y10. You go up like that right here. That's 10 right here. You go that way. Okay, this is 5, 10. See? And then the next point is 7, 15. X is 7, y is 15. And you start right there. And then you go to 15. What is 15 right here? So you draw that like that. Alright, and you go like that. See? So it's right here. The point is right here. It's 7, 15. See? It's 7, 15 right there. Okay. So now, suppose you are required to connect the point, then you can take a ruler and connect it nice and clean. It's going to be a straight line, right? You connect, let me see if I can do it. You connect the points like that. Yeah, it's going to be a straight line like that. I guess my drawing is a little bit awkward. When you connect it, it's going to be a straight line. Okay, so in physics and chemistry, especially physics, okay, let's say you're given all these points, you can extrapolate from the graph, right? They can ask you to, this could be time. This axis could represent time. This axis can represent, say, water. Let's say water running in a tub, right? Water flowing in a tub per time, right? You can extrapolate. They say, okay, let's say these numbers over here in the x-axis represent. This is at the minute 1, minute 2, second minute, second minute, third minute, fourth minute. They can ask you in the 6 minutes right here, what is the amount of water in the tub, right? So you can go like that. You go up to extrapolate it. Then you go like that. Then it will tell you that the water, whatever it represents, whatever this represents, maybe cubic or whatever it represents, amount of water. So you can extrapolate using the graph. See, you can extrapolate like that. Like that. You can even go the other way. Start from over here on the y-axis, and then you go to the graph, and then you go down here, find what x corresponds to it. So this is very useful in solving practical problems. See, you can model practical real-world problems using linear functions, And then to represent the linear function, you need the Cartesian coordinate system. You draw it like that, and then you draw the graph, and then you model whatever problem you want to model. I think I'm going to leave it there. Please subscribe to my channel, like and share this video. Leave comments and questions under the video. All right, thanks for coming.